Hi guys, welcome back to the Astroimaging channel. After a long break, 2 weeks off, and we're back. Tonight's session is an open session. There's no specific topics, so basically I ask you to suggest topics in our chat, which you can find on our website, theastroimagingchannel.com, in the little bouncy thing on the bottom right. You can pop that chat out and make it more user-friendly if you'd like. I'm sorry, I'm just laughing at a comment coming in there. Thank you. Someone likes my haircut. But yeah, I've already got a few topics here. But before I jump into that, as always, I do want to show off our image of the week. And I got to tell you, this is, I don't know, I haven't imaged in a long time. It's probably been, I don't know, it's been months. I have sat down and processed some of my last data. But what ends up happening is I'm processing the same data, and it's like late summertime data, early fall data, and I'm forgetting what objects are coming around. And all of a sudden, I saw this pop up, and I realized, oh, it's Orion season, I guess. It's that time of year, and a few great Orion images were submitted, and this is one of the better ones, done by Chris Gomez. So Chris, congrats on the image of the week. You guys can always go to our website and check it out and leave a comment on it. The way you submit is by clicking that right there. And the way you check out the images is just by going there. You can also check out the submissions at the same time. You can click images and comment on them, etc., etc. I think most of you guys know how it works. Sometimes the images don't always pop up on the screen. I do see them on the back end, though, and a lot of the times I see like 3 or 4 or 5 of them, so I can tell you haven't seen them up front. And occasionally they come along with an email, hey, can't get it to post, but I see it, so don't worry if you don't. Let's see here, taking back my screen. Okay. So if you're, I'm not going to call out anyone mount manufacturer or anything like that. I just don't want to do that, because this type of thing happens to a lot of people in our hobby. It's a low turnover hobby. It's a low, there's not a lot of people in our hobby, and equipment issues sneak their way into just about everything. And I always say nothing really works out of the box, particularly in imaging. Maybe in visual observing or visual astronomy, you're going to get a lot more out of the box, perfect performance. But in imaging, everything takes a little bit of tweaking. Some of the premium mounts will require very little tweaking, but may require just a slight learning curve. But they come at a huge price. And someone's having an issue with the mount that they purchased, and it's been replaced a few times. They're wondering, how do you light a fire under their butt? How do you get them to do what you want? It's been returned 3 times. Came back with issues each time. Possibly was replaced in the meantime. So what do you do? You know, I can really only say, yes, it's frustrating. Make sure you tell them what you want. Sometimes you give them an opportunity to fix it because you really want this mount. But after trying a few times, it hasn't worked out. And sometimes you just have to say, you know, give me my money back. Let's work it out that way. I'll spend it somewhere else. I don't think you guys are going to be able to fix it to my satisfaction. And they may be happy to do that after shipping something back and forth across the country 2-3 times. At some point, they might just want to walk away from it. That said, is it always going to turn out that way? I don't know. I will say the mount manufacturers, including the one that you're having difficulties with, I've had good luck with. All the mount and equipment manufacturers I've dealt with, yes, I've had issues. I can think of a bunch of issues that I've had. Basically, almost with every piece of gear I've had to call customer service and have had to walk them through it. But if they're responsive, and if you can talk to them and get a hold of them immediately and they're willing to work with you on that issue, it's worth something. So just because you have an equipment issue, I wouldn't immediately discount that manufacturer's quality or customer service, because I don't know, it's a crazy hobby we're in, right? Everyone has issues. I joke that it's not the CCD cameras that are sensitive, it's us, because like really, like what is it about all of our equipment? We're so particular about our power source, our power supply. We set it up in a particular way, and we still have issues. I don't know. I can't answer it. But that's basically my advice. Talk to the manufacturer. Give them a chance to resolve it, but at some point say it's time to walk away, and make sure you tell them what you want. Before I jump onto the next topic that I'm just going to hover over right here, anyone else have any comments on that within the room? I'd rather not call out the mount manufacturer, because like I said, I think this could happen to any manufacturer, but go ahead if you want.
Yeah, I'll add, you know, my sentiments are pretty much the same, Adam. I want to give the people an opportunity to fix things and make it right, you know, and as long as you're clear with them and upfront, you know, and if it doesn't work out, it doesn't work out, right? You know, you have to, you know, set some goals, you know, some rules for yourself so that you know when you're going to pull the plug and move on if things don't work out. But you know, that's entirely personal when that time occurs, right? So it's just something you have to decide for yourself, whether it's then or later, or whether you work it out until it's fixed, right? So
Yep, it's I don't know. You just have to deal with it whichever way you can. You always have to, you know. I always find being polite and just being sincere and saying, you know, I really want this to be working, but it gets you further than if you're screaming at them. But that's my way. I know other people scream at them and get their way that way, but nobody wants anything to go wrong. Everyone tries to get it right for the most part.
Adam, can I jump in?
Go ahead.
I think one of the things it's really good to do is to know who you're talking to. And the way you get to know who you're talking to is to deal with a company. I happen to live between OPT, Woodland Hills, and not too far from Orange County Telescopes. Aren't too many people who can, you know, have that kind of facility within an hour and a half of their home, like I do, across the country. There just aren't that many big telescope stores. But you don't have to physically be near them to have a relationship with them. You know, you talk to a lot of these people, Chris and Dr. D and the people that are working Farah, you know, they know you even though they've never met you in person. They know what your needs are. They know, hey, yeah, how's it working with that such and so and thing like that. Now, the way you do that, of course, is that you establish that relationship. You tend to buy from that person. It will maybe cost you a little bit more, or maybe not, but it may cost you a little bit more. But the trade-off you get for that is that when they know you're not happy, they'll do something about it, and that helps a lot. So it's always a good idea to know the people that you're dealing with if you can, and not just go to the lowest price off the internet someplace.
Good point, Alex. The next topic that I think is definitely worthy, more than just worthy, RC collimation, specifically the GSO types. Now, this deserves its own show, and maybe this would be a great next show for me to do. I'll see if I can get it together. Oh man, the thought of going out into my observatory right now. I think it's 0 degrees outside. So I always feel like RC collimation is a spring and fall type of thing, but maybe I'll sacrifice and try and do it. I bought a 10-inch RC, And of course, the RCs have great optics. If you like diffraction spikes, then they're perfect. They are relatively the GSOs are relatively reasonably priced and almost bargain priced for what you actually get out of them. What's the catch? Well, collimation is pretty difficult on an RC. You almost certainly will need some additional part, some additional there are a few different methods to do it. Some people use, I believe, a collimating scope, and I'm not quite familiar with that method. The method that I'm most familiar with is using a laser collimator, and I specifically use the Howie Glatter laser collimator. I'm going to pull this up right here. Basically, whichever size you need, whether it's 2-inch or 1.5 inch, or they have the combination, so it works both ways. You insert this basically into your focuser, and oh, I'm sorry. You first also need to buy an attachment called the circular holographic. What is it called? Circular holographic. Let's see if I pull it up. It's probably an accessory under here. It is not. Well, what it does is it turns the laser point into a circle, and it allows you to project it onto a wall or a piece of cardboard or fiberboard or something, and you just look at the rings, and by looking at how concentric the rings are, you can collimate it. And you actually, it's an iterative step going back and forth between the rear mirror and the secondary mirror. But you can get your collimation pretty close. I say pretty close because the odd thing about the RCs are that having the mirrors perfectly aligned doesn't necessarily mean that the optics are perfectly aligned for the best image. And I'm not explaining that correctly. But basically, the mechanical alignment of the mirrors may not be the perfect optical alignment for the system. So after I do that, and that's actually really easy to do because I do it during the day. All I need is to like close the observatory roof and project it onto the wall, and I can see the rings pretty clearly. So I do that during the day, and then I take my camera out and I basically finish the process using this process, the Deep Sky Instruments procedure. It works the same exact way that it would whether you're using a DSI telescope or your own telescope. They go through the traditional collimation method here, the collimating scope. I believe everyone uses, the Takahashi. But they come up with some of the pitfalls to that. So you go all the way down here, and it's also an iterative process. They explain a little bit about how the process works. First, you orient your camera sensor so you know which way is up. And then you remove the coma by adjusting the primary mirror. You go down, and it shows you the process for doing that. And then you do what they say is balancing the images, which is balancing the image, which is basically making the stars and the edges all have the same shape. If they're radiating in one direction, you want them to radiate away from the center. And I'll tell you, it's a really long, complicated paper for a relatively simple process that can make a big difference on your image. Now, I'm not saying you're going to immediately go out there, collimate, have it done in 10 minutes or so. It might take you an hour, but if you're in an observatory or if you're gentle with your equipment, you're probably not going to have to collimate so often. And I don't know, it works for me. That's my method. I was asked for the method. I think that's probably the for the way that I do it in the observatory, wanting to get it close during the day. I think it's one of the best ways for me. Let's see. Going to take my chat back. I heard a lot of little pops, which mean, or a lot of little, what should I call them? Little blips, which means people are commenting on something. And I'm going to have to jump down to the bottom to see. Yeah, and Bill had posted a Howie Glatter holographic attachment concentric circle pattern is what they call it, which basically allows you to get that concentric circle pattern and collimate. Yeah, it looks like a lot of. Will that collimator work with an SCT? I don't know. I'm trying to think about it. I wouldn't be able to say one way or another.
You know, I've never had a problem with, I'm getting an echo. I've never had a problem watching, using my fingers to collimate, just off a star test and things like that. Laser collimators don't actually tell you if you're properly collimated. What they tell you is where the beam is coming back to. Now, it doesn't make sense to me that you could use a laser collimator and just bouncing it up to the secondary and back, because all you would find out is that you have a spherical mirror. And wherever you hit a sphere, it's going to bounce basically, among other things, straight back to you and straight back in every other direction too, but you'll only see the one that's coming back straight to you. What's his name? David up in Rancho Cucamonga there. David Ho makes a laser or an SCT collimating system that I've seen in many places, and I know that several of my buddies have them. David's a friend of ours. He's a good guy, very good guy, and I've seen him demonstrated 1,000 times. For my money, it just seems like, boy, it's almost more complicated to set up than looking at a star and twisting my fingers around. And answer to your question is, I don't think a laser collimator in itself helps that much with SCT collimation. But when properly used with the rest of the tools in David Ho's system, yes, it does. Eric, did you buy one of those up at the Advanced Imaging Conference, or was it somebody else I was hanging around with the ball? It wasn't Eric, or Eric's asleep, one or the other.
I had one of them, and the Hotech laser collimator. Yeah. And it worked. I mean, it worked as it was supposed to. I could collimate the SCT during the day using it, but it didn't work for me for one reason, or it didn't work for me as intended for one reason, and that's because the floor in my observatory is wood, and I put it on my camera tripod, and just walking around my observatory would shift the collimator enough that I just couldn't use it the way I needed.
Yeah. I'm sorry, Alec, you said something. I just stepped out of the room.
I was just asking, did you buy one of David Ho's SCT collimators, or was that Bob that did that? I think it might have been Bob.
No, I had the 8-inch RC, and I had the Howie Glatter collimator.
Okay.
I went through all the procedures exactly as he described it, and got it perfectly visually collimated with the laser. Mm-hmm. But in the end, you could never get the stars completely round from corner to corner. Mm-hmm. And that turned out to be just a matter of the optics being a little bit pinched. So in addition to collimation, you have to make some judgment on the quality of your optics. And, to be fair, perhaps there are some scopes which are of higher quality than others. And I ended up with one which wasn't, and now it sits in the telescope museum downstairs.
Bill just chimed in over on the comments that using a big star cluster works best. And yeah, I mean, it's a lot easier to do than trying to line up everything. All you got to do is figure out which knob moves the circle which way.
Yeah. I'll be honest, with an SCT,
yeah,
they're easy to collimate. It's almost like no concern because it's so easy to collimate. And I spent, I don't know, maybe a year and a half, 2 years with my first SCT, afraid to collimate it because I could screw it up. And I look at some of the images that I took, and I was way out of collimation. And I could tell just by looking back, I could tell the first image that I took where I had actually collimated it. First time out, you know, we're all very particular. Like I said, first time out with a screwdriver at night before I got my bobs and knobs. I had it much, much better. I don't know, collimating an SCT is very easy. So I wouldn't even worry about anything in regards to any additional equipment. Possibly the bobs knobs because just scares me with having a screwdriver right there with that with the corrector plate right there, but that's just me.
Oh, I just thought I'd tell you that I have a 12-inch RC. I've had it for, what, 2.5 years, I think now. And it came out of the box, and it was, as far as I could tell, perfectly collimated. And I haven't had to touch it since. And maybe my standards aren't high enough, and I haven't ever taken it over to CCD inspector to do the checking, but it seems good. Seems real good. So I don't know anything about collimating it, except that when I need it collimated, when I do need to collimate it, I'm going to walk down about 7 or 8 observatories and ask one of the guys from the store to come on over and collimate it for me, which is convenient.
When I bought my 10-inch RC, I bought it used, I believe, on Astromart, and it was one of those purchased, tried using it once or something like that, and decided to sell it because I never really had the time. So I had the feeling that when it showed up, it needed to be collimated, only because I feel like if he used it once and he loved it, that meant it was collimated. And but I just had a feeling, and it was all decked out. It had a big enough focuser. There was no reason why it shouldn't have basically a ready-to-go imaging system. But I had that feeling when I got it. I was going to need to collimate it, and it was way out, completely unusable. If it showed up in anyone's hands and they were expecting to not have to collimate it, they'd be in trouble. I think I had purchased the ladder collimator in advance, expecting to have to collimate it, and knowing me, I probably read every manual and everything about RC collimation that I possibly could for the 3 weeks prior. But yeah, so our RC collimation, it's the disadvantage of an RC. But once you get beyond it, you've got a nice system that's really optimized for imaging.
Bill's asked Alex a question, so I'm going to answer it. What is the best thing to do when you first get your RC out of the box and want to see if it is in line? I can tell you what I did. I don't know if it's the best thing. As you know, while I talk a lot about imaging, I'm not necessarily the best imager out there by like a long shot. And I may not be as picky, and somebody else could be looking at this saying, geez, Alex is way out of collimation. But the people that I have asked to look at it, my buddies who do know what they're talking about, seem to be pretty impressed with it. So that's why I can state that it is in collimation. Having said that, you have to understand that my club, Riverside Astronomical Society, has a dark sky site with 22 observatories and 30 or something pads and all sorts of other stuff. So, you know, I do get to have other people come over and look at my stuff now and then and make sure it's okay, even if I couldn't maybe do it myself. But I'll tell you what I did do and what other people did with me at the time. First thing I did was I put an eyepiece in it, and I made sure that just with the standard old eyeball with a slightly defocused star, and got circular, you know, everything was circular. That, yeah, I did that just the other day, just for the hell of it, and everything was perfect. Then I put a camera on it, obviously, and I've taken pictures of it. I've taken lots and lots of pictures with it, and I've studied them in with the aberration inspector, and I've studied them in PixInsight, and I've studied them. I haven't ever sent it off to one of my friends with CCD Inspector, because I can get an actual report on collimation there. But there's also, what's the aberration inspector? And that's not the, no, what's one that gives you 9 different pictures of each edge, and look up into the edges and see if the edge looks the same as it does in the middle. If you take a picture of a star cluster someplace and see if the pictures of the stars, the shape of the stars and the edge at decent magnification looks the same as the stars in the middle. Now, having said that, I think that some of the other people on the forum here can tell you how to tell by looking at a picture, or which convenient tools to look at that would be able to, that you'd be able to figure out if everything was okay. Who else has something to say on that?
Well, I had RCs, a few of them, and I collimated a few of them. And if it's out, you'll know.
Okay.
I mean, it produces ridiculous aberrations. You know, you'll have elongations and astigmatism and all kinds of stuff.
So you're saying you could do it just visually? You can just do it visually?
You could do it visually. Well, if it's only out in one, if the secondary is out, yes, you could do it visually. If they're both out, no, you cannot do it visually.
Well, if you can't do it, I mean, if they're both out, what happens? You just doesn't focus well, or what?
Well, you just don't know which way to go. If
no, okay, you're talking about how to fix it.
Yeah, yeah.
I'm talking about, I've just taken a picture. Can I tell if this picture is collimated properly, or if the telescope that took this picture is collimated properly?
Well, from the based on what you said, yes, you could. If it was out, and especially with that aberration inspector from PixInsight, you're gonna see weird things. You're gonna have elongation on one side. You're gonna have spikes on the stars. You're gonna have weird aberrations.
You would know it's out. You wouldn't know how to fix it.
Yeah, if they're both out.
Okay, yeah, that's I've never seen the weirdnesses, so I've never collimated my RC.
Yeah, exactly. Leave it. Don't touch it, because if you take it out of whack, then it's hard to put it back together, especially if you play with both of them.
Yeah. Okay.
There are four things that could go wrong. One is your imaging system could be off-center, not in the center of your light path. 2, the secondary mirror. 3, the primary mirror. And 4th, the distance between the mirrors. On an RC, that matters too. So how the heck are you going to put it together if it's out? You have 4 axes you need to worry about.
Yeah, and the distance between the mirrors, the tolerance is really tight. So I don't even know. Somebody in comments posted, I think this is what they're referring to. How do you reset? Which in my mind goes back to a post that John Rista actually made years ago about RCs and the reset method. Because sometimes if you've tweaked and tweaked and tweaked, you've adjusted the distance between mirrors. Mm-hmm. I'm probably going to say we'd have to Google it to find out exactly what his method is. I don't remember whether it was bringing either the primary or the secondary all the way out and then returning them, or what it was. But
well, with a plane wave, I mean, I know we're not in the same
Right.
price range, but with a plane wave, they give you a Ronchi eyepiece with a special spacer, which it's an X amount, and then you put this eyepiece on, and then they give you a picture of what the star looks like, and then you play with it, and you bring it back to where it was. With an RC that doesn't have a system like that, the only method that I know you could set the thing is to actually calculate your focal length backwards from your image scale. So you put a camera on, like let's say you're talking about a 10-inch RC that is supposed to be 2,000 millimeter focal length. You put a camera on it, you figure out your image scale, calculate your focal length backwards, and then play with the mirror spacing until you get it back to 2,000 millimeters. What else are you gonna do?
yeah, no, that's a good idea.
Before we leave this, could we look at Bill's second question there about he's having a tough time getting his off-axis guider to focus, and I want to ask a question about that or two. Whether it's you realize that in an off-axis guider, it isn't going to look focused. Your off-axis guider star is not going to look pretty, virtually whatever you do. If you're trying to work it so that your off-axis guider star looks like a star, you're probably going to be disappointed. Okay, you're just too far off axis by the time it hits the pickoff mirror. Bill, is that where you're going with that? Is you trying to get a focused star or a good-looking focused star out there? You might have to type in your answer there so we can see it. It's so out of, okay. If your off-axis guider is so far out of focus that you cannot see the stars, then what you need to do is, first off, well, here's what I would do. I would focus my main guide camera, and I would mark where exactly it focuses physically. You know, how far, what stop it focuses on, and things like that. And then I would rack the focuser in or out until I got the off-axis guider to start showing me the stars the way it should be showing me. And I would measure at some point, if you just keep running your focuser out 1,000 steps and try it again, or another 1,000, another 1,000, at some point, that focuser will get to a point where your lodestar focuses. Now, measure how far it was from where your sensor in your main camera was focused and the sensor in your off-axis guider was focused. Remember, they're both sitting in the camera. They're both, they're all attached to the off-axis guider. So by now, by the time you've got your lodestar focused, your main sensor is going to be way out of focus. But just measure the distance between those 2 points of where your sensor was focused and your lodestar was focused. Your main imaging camera was focused and your lodestar was focused. How far is it? Is it a couple of thousandths of an inch? Is it a quarter of an inch? And which direction is it? Does your lodestar focus further in than your main camera does? If your lodestar focuses further in than your main camera does, you need a spacer. That distance, the distance that we've been talking about, you need a spacer that far between your off-axis guider and your camera. If your lodestar focuses in further away, then you need to put a spacer between your lodestar and your off-axis guider. Does that make sense to you?
Yeah. So
Okay, you have to rack your focuser all the way in with the lodestar to get the focuser where you need it. Okay, then if that's what you have to do, then measure the distance there, and you have to somehow add that space to the distance between your off-axis guider and where your lodestar is. Now, it may be that you're going to want to add an actual spacer, or it may be just in the way you adjust your focusing. You know, you may be able to pull it out and put the set screw further out, or any variation thereof. But you understand the concept now, right? I hope. That makes sense, guys?
If he has to rack his focuser in, it's that he needs more inward focus for the lodestar.
Right. That means he needs to put more distance between the guider and the camera and the main imaging camera.
Yeah, yeah.
Okay. You added a 7mm spacer between the off-axis guider and the lodestar. Okay. Yeah, that's generally it. Okay. Hope that helped.
Yeah, I mean, I usually if you just look at the actual mechanical distances involved, you should get an idea. Like, you could draw yourself out a schematic. If you have the pieces right there in front of you, it's basically just figuring out, in reality, where the spacer has to go.
Is anybody else? What's the name of your off-axis guider, or is it part of what is the name of your camera? ATEC. Is it an ATEC camera, an ATEC off-axis guider? ATEC 1. Okay, no, I have no idea what that means. Yeah, but basically, you know the concept, and it may be scoped up, or you know that you got a 1 1/4 inch front end on your lodestar. Just go get a 1 1/4 whatchamacall adapter from the old visual people. Okay. Oh, it's got a built-in filter wheel. Yeah. Then you need to put space between that on-axis guider and the lodestar. You need to somehow do that. And if you're dropping your lodestar in, try not dropping it in as far. Maybe get a parfocalizing ring that'll help hold it just further out than that, or something like that. And you're not being a pain. That's actually what we do here.
Yep. I'll tell you, setting up, people say off-axis guiders are difficult to use. No, they're difficult to set up. And then once you get them set up, you love having it.
If you've got a good one, and it's sensitive enough to show you what you're supposed to be seeing.
Yeah, yeah.
But you will never get a nice, pretty star out there. You'll just get something that you'll get a piece of light, and it may not even be a round piece of light.
Let me share my screen. I'm going to show a diagram. You guys see this?
Yep. Yeah.
Okay. So I know this is not your off-axis guider, but this applies to all off-axis guiders. So what you need to do is that the A and the B needs to be this over here. This distance A, which is the distance from the prism to your guider chip, has to be equal to the distance from the center of the prism to your camera chip. Does that make sense? I know this doesn't apply to yours, but this is a general diagram. It applies to all off-axis guiders.
Yep. Yeah. It's a good, I mean, I drew out a schematic for my own camera. A couple different off-axis guiders I had with my DSLR, just so I was sure that it should come to focus. And then, of course, you actually try it in reality and see if it does come to focus the way it's supposed to. It was one of the motivating factors for me to buy an integrated off-axis guider with my SBIG. One of the reasons I liked it. It's both a good thing and a bad thing at times. just trying to scan through all the questions because I think we're mostly caught up with what I've seen. Do you have to use an off-axis guide, or can I use my guide scope or even an SV80 for that on a 10-inch RC? Weight isn't an issue, tight mount. I would love to say yes, but I'm very reluctant because I think you're going to have some sort of differential flexure. You're going to spend so much money on getting rigid enough connections between your RC and your SV80 that you may just be better off having an off-axis guider. If you show elongated stars and you're having unexplained elongation, which is most likely coming from some sort of differential flexure, then you need to tighten down your equipment, right? You need to make sure your rings are on tight, make sure the mounting scope is tight, make sure the focuser on the piggyback scope is perfectly tight. Make sure it's not the focuser on the RC that's shifting a little bit, because any difference in shift between the guiding camera and the imaging camera is going to show up as elongation. Other things can cause elongation. Bad polar alignment can cause elongation. So now all of a sudden you're thinking to yourself, is my polar alignment bad, or do I have differential flexure? Is the differential flexure coming from this focuser, from this focuser? Well, it's bothering me enough. I'm going to replace the focuser on my guide scope. You do it. You spend $300-400. You might as well just buy an off-axis guider. Having struggled with differential flexure, having seen so many people struggle with the same exact thing, not having seen many people overcome it with a rigid enough connection in any way, that's my opinion on that.
Adam,
Yes.
I'd like to go back to, I keep getting my echo. I'd like to go back to a question that remember we were talking earlier about the how do you tell if your image is screwy or not? I got to share my screen. Screen share. Okay, we're looking at a Pix Insight screen.
Yes.
Okay. Oh, by the way, before I go to the Pix Insight screen, there's a fellow who's been communicating with me back and forth, and I don't know if he knew about the Astro Imaging channel or not, but I wanted to just go through this again for the people that don't know about it. If you're just new to the Astro Imaging channel or something, you'll notice that we're reading questions and things like that from people. In order to get into the questions, you go, am I in the right one? Yeah. Where should I be? Oh, see this box down here, this funny looking circle or oval? It says 39 in it right now. If you haven't done it yet, click on that and sign in as one of us, and you can ask your questions by typing a message in right here. Okay, and having done that, then you can ask your questions and get on with it. So if you didn't know about that, please go ahead and do that now. Why don't we go back to, okay. This is a picture and this is just a raw picture. The only thing I did to it was do a histogram stretch so that it would show up better in what I'm about to do. And you can see that it's got some background aberrations in it. It's not flat as it should be and some other things like that. But if you go to script, image analysis, right? And the aberration inspector, I think it is, right, like that. And just take the, you get this picture over here. I'll get rid of that one and make this one bigger for y'all. And what this does is it grabs a series of frames out of whatever picture that you've got that you're talking about. So you can see that this set of stars up here, that's this set of stars right up here. And this is this one. And this over here is this collection of stars way up here. This is what the center of my screen looks like. This is what the corner. So, you know, it's kind of hard to keep your eye trained to look from here to down to there to up to there to over there to see that you're getting identically shaped stars. Now, these are not perfectly round stars, and we were having some problems that night and stuff like that. And it was a fairly moony night and other things like that. But you can see that when I say that my star shapes are about the same all the way across the field. In the middle, the lower left, the lower right, all the way around, they're about the same shape. And that tells you that you're probably in collimation. Okay? That's just one of the things I wanted to share because of that part of the conversation we were having.
Thanks, Alex. And the I believe CCD Inspector has a live version or something along that lines of that.
Well, there's actually several others in here. I'm not really familiar with them because I don't play with them all that much. But there's some pretty good ones in here. What's the other ones like? Which one do you guys want me to try? What's Aberration Spotter do? Pink. That looks like it's the same thing.
Mm-hmm.
Okay. So you can try to pick out what's causing your problems. But if your stars look pretty much the same no matter what, well, you're probably in collimation and everything is working the way it's supposed to work. And if you don't happen to have Pix Insight, all you got to do is clip, 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 and put them all together in one picture, so that they're just easy to look at back and forth.
Probably easy to make an action in Photoshop, do the same thing.
Yeah, you can do the same thing in Photoshop or anyplace else.
So a question about the on-axis guider. We've actually had Gaston Bodat on to discuss the on-axis guider, and it's a very interesting product. It is pricey, but more recently, he's introduced a few new. It's a piece of hardware and a piece of software that adds some really cool new features to it. Basically, live focusing. It focuses during the image. It focuses while you're imaging. So why would you want that? Well, for some of us that shoot narrowband, for shooting half-an-hour exposures, and we want to be shooting 1 hour long exposures, but the temperature change is a little bit too much to handle, then it can keep you in focus basically all the time. At the same time, it could provide just basically a slightly more accurate focus throughout the image. But there's and he's calling that focus lock, I believe. But then the on-axis guider itself, just as an on-axis guider, is really smart. The way it's designed, it picks off the infrared light and sends that to the guide camera. Infrared light is less impacted by atmospheric impacts or seeing impacts. So in theory, you should get a tighter star in the guide camera image, which should give you less spurious guiding corrections. It's, I don't know, it's cool. It's really smart. It requires a lot of back focus, so it's probably going to be compatible with a lot of systems like RCs and maybe some of the premium optics systems that, or the premium systems that really are generous with their back focus. You might be limited. You're almost certainly limited if you're using some refractors, or I believe an SCT might not might have issues with it depending on what configuration you're using or what focal reduce you're using. But I will say this: I've seen a lot of people using it successfully and very happy with it. So it's a product that the Astro Imaging channel can vouch for, even though I can't vouch for it myself. How much does it cost, ballpark number, to design CNC parts for a mount? Trying to adapt Heidenhain encoder to his mount. That is very difficult to say because, first of all, I'm not a machinist, and I've only basically had parts designed in those online configurators, and mostly just
Spacers.
spacers. Yeah. Having a custom part designed involves getting into a CAD program somehow, making sure that CAD program is compatible with however they're going to machine it, choosing the material you're going to use, the type of aluminum itself, if you're using aluminum, can vary considerably. It's almost impossible to say. The best thing you can do is basically try and find a specialized machine shop and walk in and tell them what you want to do, maybe even with your mount. Maybe there's someone who's already trying to do that. Maybe a mount manufacturer would be able to help you with that, or somebody who kind of understands what we're doing with telescope mounts as opposed to just a generic machine shop. But it's hard to say. Yes, go ahead, Eric.
I think, the first place you'd want to check would be Precise Parts.
Mm-hmm.
And just give them a call, because I think no matter what the adapter that you want, they can likely make it. What the cost would be, of course, we don't know. But routinely, these adapters run a couple $100, maybe a little bit more, a little bit less.
Now he's trying to mount an encoder to his mount, so I'm going to assume what he's actually looking for is an adapter that's going to create a bracket to hold the encoder in the right spot.
I would still give them a call. You'd be surprised. I mean, that's what they do for a living.
You know what I would do is if I knew how to run a program that could at all design the part, and there are such programs, because we've even done a show on the Astro Imaging channel about this, and Josh did it. And then I would take it down to my local library where there's a 3D printer maybe, and have it made. Or I would have Edmund, who's asking this question, get in touch with Christoph, who just a little while earlier said that I also work at a machine shop, so I can make dovetails, and he didn't say it, but I'm sure he could make almost anything else. So just go make a new friend.
Yeah, I think the difficult thing, I've done some of the CAD programs for custom parts. I think the difficult thing is actually measuring the part you need, right? How do you measure it precisely? That's always where I've struggled. If I knew the measurements, then I could basically design it in the CAD program. But not knowing the measurements is what makes it difficult. And I'm not just talking about the bolt-to-bolt measurements. I'm talking more about how much space do you actually need so that it's so that the encoder is lined up properly wherever it may need to be. And maybe that's why I'm not a machinist.
What and it really depends on what you're trying to adapt. If you're just trying to get it to hold still there, you may be just fine with bending some sheet aluminum or something like that. I mean, when you buy a RoboFocus focuser, the mounting kit consists of a couple of pieces of aluminum that you're supposed to bend until they fit right. Seriously, that's what you get. But now, if you're trying to actually get the parts right, remember, whoever designed this thing in the first place probably designed it with standard threads and things like that. So a collection of nuts and bolts that might work. And again, if all you have to do is hold it in place, it may not take much more than that. But did you see, flip down, I don't know if you've gotten there, because we're kind of, there's this whole list of questions, but Christopher's kind of responded, Christoph McGihorn. Anything that's custom made is usually pretty high, custom made, since they only make one piece of it. Okay, and that I can tell you that I have worked in a machine shop, but I've worked a mill and some other things, and it takes forever. Setup is forever to get it right. So be careful. If you've got to thread stuff and things like that, it's an even bigger job. If all you got to do is bend them to the right, or shape them to the right place, and mill off the excess aluminum, that's not so hard. But okay.
Okay, question new to TAIC. First question came, moving on. Watched a 3-year-old recording selecting a target and framing it using Sequence Generator Pro by Alex. It was really nice.
I
But
was so smart back then. I was really smart back then. Yeah.
it all goes with age, right?
Yeah.
3 years ago. But as explained in the recording, normally uses Stellarium to check whether the object will fit in the field of view for your telescope and DSLR. Question about configuring the DSLR and Stellarium sensor list. Since the DSLR has a crop factor of 1.6, so use a 0.63 multiplier lens. I remember Stellarium's framing thing being very confusing. I can't say I know enough about it. I know enough about it to know I was confused when I was trying to do the same exact thing.
You know, there are a number of applications that would help you a lot. AstroAid is the one I use, and AstroAid allows you to put in a, would you do me a favor, Nicole? Would you go ahead and tell me which, well, you got a T3i, tell me what your scope focal length is. Just type that in and I'll go compute it for you and I'll take it from there, okay? But I gotta go and get my phone.
And Chris Gomez is getting a shout out. Bill loves your images, Chris. Good job. Especially this week. Yeah, anything custom made is usually pretty high. Making one piece, they're doing it all for you. And there's a reason that they do it professionally, because it's not necessarily easy to do. And not everyone has a CNC machine in their basement, right? We all wish we did. Use stereolithography instead of filament for 3D printing. A filament deposit, which I guess gives you a more smooth part. Wish I had a 3D printer. Does anyone have the Rayox saddle? If not, then I cannot tell you what anyone thinks of it. I'm sorry. Not familiar with it. Yeah, in Sky Safari, you enter the physical dimensions of the sensor along with the focal length of the OTA. If Stellarium's the same, you don't include the crop factor. I don't know. I don't remember what it was that I had to do. Maybe just having the square show up somehow.
Well, yeah, crop factor is make-believe. It's a technique to sell stuff, okay? It has nothing to do with changing your actual image. You have to remember that. What you need to know is how wide your sensor is and how high your sensor is, and that will tell you, and you need to know the focal length, and there's actually a number you can divide it by. There's a couple of programs you can get off the web. New Astronomy Press, Ron Wadowski CCD calculator. There's one that you can go to. Oh, yeah, I should probably do that instead of doing it on AstroAid on my phone. But there are several you can find out the dimensions of your Canon T3i and take it from there. And that's what I'm trying to do over here. You know what? Let me go to StarZone and see what they got. You guys talk amongst yourself.
Bill's asking if they make a helical focuser for the Lodestar to C-mount on the Attic one. So I'm sure you could buy a helical focuser C-mount, excuse me, a helical focuser that in some way would adapt to that. And it's good to have a helical focuser on a off-axis guider, assuming it's rigid enough. That said, just make sure that if you need inward focus, it's not impacting that inward focus, because it's most likely going to add a little bit of space, optical spacing. If you think it'll solve your distance problem, if you know you need to move it out a little bit, then yeah, possibly. I don't know whether yours slides in or out. Mine is basically just a push-pull. I just slide it in and slide it out and tighten down some knobs. So I can slide it out and say, oh yeah, well, it needs to be there. It looks like 3 or 4 millimeters, but it's basically determining the same thing that Alex said by adjusting your focuser and comparing the focus between the two cameras.
Could I have
You want the info?
back here for a minute? Yeah. You can see my screen?
Yep.
Okay. I've just called up I've called up Star Arizona's Guide to CCD Imaging by going over to type here, and I just typed in Star Arizona. And I took CCD calculators and stuff like that. And then I came over to pixel resolution and field of view. And then I came over here and I picked a Canon. What did you say? Somebody read that. Is it a T3i, right?
T3i.
T3i. I picked the Canon T3i, and I don't know what telescope he said, but what did he say? 952? 932? Whatever it is, 952. And then I said, calculate it at 1-to-1 binning. And I know that it's 0.93 arc seconds per pixel, that the field of view is 80.5 by 53.8. Now that's the information you need to make a custom field of view indicator over in Stellarium or any other program that you're using. They may even actually have a database with all this information already in it. So does that help you?
Hope it does.
Okay, where am I?
Yeah, Bill's saying the attic one does not allow you to slide, I'm assuming, the guide camera in or out. So you probably screw it down. But I could see where that would be a little bit difficult to work with. How accurate does guider focusing need to be? Also, what SNR range should you be looking at in PhD2? Conventional wisdom is that guider focusing does not need to be very accurate. The way that the centroid of the star is determined just does not require a precise pinpoint. That said, I've never really heard a strong argument that says being intentionally out of focus is going to give you much better results or better results at all. I know in some types of astronomy, intentional defocus does give you benefits, but I just don't quite see why it would in this case. So basically, try and get it as focused as you can. If you see as Alex said earlier, you're talking about the edge of the field, so you're not going to be able to get a perfect, pretty star, most likely, unless you're talking about premium optics or some unique system. So get it as close as you can. You don't need to use a Batinov mask on your OAG. It may work. It may be too far off axis to work. But if you see dots there, you're in pretty good shape. The SNR, that's a hard one for me to answer, because I always used to go by in PhD. I always used to go by, I think it was like 4 or 5 as the sun was setting. I was starting to get 4 or 5 SNR on my stars. And then when they updated, I don't know if it was to PhD 2.0, the SNR was just a completely different number. I want to say that it was in like the 80 to 100 range. So that's a hard one for me to answer, and I don't quite understand enough about how it's determined to really answer it. So I don't know if anyone in the room would be able to speak to the SNR range to look for in PhD 2. It might be very specific to PhD 2. So. Okay, fairly new to imaging, has been avoiding imaging through a meridian flip. Can you discuss the best way to manage a meridian flip and what additional equipment is needed? He plans to set up Sequence Generator Pro, but do you need a rotator or other equipment? No. You need Sequence Generator Pro and
a good tutorial about how to set it up if you could find one.
Yeah. But for the most part, once you set up plate solving, the meridian flip is going to work for you automatically. I don't think you're going to have. It's going to, assuming it plate solves, it's going to automatically meridian flip for you.
Here's the question that people don't ask. You think that when you do a meridian flip, all your pictures are going to be backwards because you're now on the other side. Well, that's okay. It's the job of the processing program to reorient all those pictures so that they're all together, and they do it automatically. You don't even have to think about it. That's the registration procedure. You're already using that procedure, and it knows how to do it.
Yep. Yeah. And it's actually a good thing that the images are flipped, because it puts the stars in a different part of the sensor. It kind of acts as a type of dithering, although maybe not a perfectly random dithering.
Yeah, it evens out my unflat background.
Yeah, if you have
you're
gradients
lucky,
from light pollution, if you have gradients from light pollution or some things like that, it can, because you're rotated 180 degrees, they don't match up anymore, and so they can average out to some extent, depending on how severe they are. They can help with things like that. But
yeah, but also from exposure to exposure, if it's a light pollution thing, it's probably changing anyway from exposure to exposure, and you'd have to have it lucky to. It does help, but it's not going to fix anything.
The only issue you're going to have, Adam, is if you have a long focal length scope and you set up a good guide star on one side, when you flip and you're doing something like a galaxy where the star density is not that great, you may have difficulty without a rotator in getting a good guide star on the other side of the meridian. With the wide field and nebula, it probably isn't an issue, but if you have a focal length of, say, 2500 to 3500, finding a good guide star on either side of the meridian is sometimes difficult. And when you do a flip without a rotator, you could end up basically with no guide star.
Yeah, I'm lucky that I never really have an issue finding a guide star with my current system. I always wonder, because that comes up every so often. I always wonder, what am I doing right? One thing is my S-Big off-axis guider has a massive prism. It also has a focal reducer, a 0.7 times focal reducer, and I think it's just a well-designed off-axis guider. Now it's integrated into the S-Big camera, so you have to have my specific camera to use this off-axis guider, but it is a well-designed piece. That said, it's the sky. Stars can be anywhere, and sometimes they're not where you want them or need them at the time. So I can see why that would become a problem, particularly with long focal length, just a tiny piece of the sky. I'm sorry, just reading through.
Going back to the manual on Sequence Generator Pro. There is a, I wrote a manual, I wrote a tutorial a while back. And am I screen sharing? No, I'm not screen sharing. I'll just go show that to you while Adam's catching up on the questions. Where's my screen share? Share. And make you disappear, Adam. And over at alexastro.org, which is my own website. Go over there. Oh, that's weird. It didn't show up. alexastro.com. And you go over to articles, and this is the Sequence Generator Pro tutorial. And it's called Sequence Generator Pro the first week, and it takes you through all the stuff you need to know to get your Sequence Generator Pro set up. And in here someplace is, I don't know, someplace in there is a complete set of information about how to set up for running the the flip. But really, it's meant for you to go through the whole procedure to set up the whole thing one day after the other kind of thing. Okay. Where are we?
Yeah, and cable management, if you are beginning to use an automated or a non-automated meridian flip, make sure your cables are fastened down your preferred way. Some of us choose to do it through the mount. Some people that even that's mounts even can handle through the mount cabling have chosen to not do it through the mount because they prefer a different way. Some mounts can't accept through the mount, so you have to devise your own techniques. But Velcro cable ties, kind of whichever, zip ties, duct tape if you have it, basically whatever method. You just don't want them waving with the wind, dragging on anything. But otherwise, you get them fastened down and you shouldn't have many issues. Does anyone know the diameter pitch on the back? I don't know. You'd have to call TPO or someone to ask about the pitch on the back of the GSO. It might be in the manual. Someone like Precise Parts probably knows it as well. It might even be on their website, but not off the top of my head. Did I say the thing about flat?
6 and 8 is 90 millimeters, and 10 and up are 117 millimeter. They're metric threads by 1 millimeter, so they're not the standard.
Adam?
Yep.
I just posted a link, which is not the video, but the posting on AstroBin and a complete description of managing cables so they don't hang.
Mm-hmm.
Using those elastic wraps and a couple of loops. So if you want to pass that along.
Just posted it in chat, and let me share my screen. AstroBin, the Rig Runner solution, or no more dangling cords. Let me see if I can share. I'm sorry, I have a million windows open, and that is not the right one. To Chrome, to here. On AstroBin, Eric's posted this article basically about his method for getting rid of dangling cables. And it's a method. You posted this a while ago, Eric, right? Are you there? Is anybody there? Yeah. Because a lot of people have basically begun using this method, not just for the rig runner and the dew heater, et cetera, but basically getting the PC on top of the mount and having an all-in-one solution all up there. So you really...
Well, the main thing about this is, it's not necessarily having everything on top, although that configuration does. it's those two loops which allow rotation on the RA and deck,
Mhm.
and still giving plenty of slack, where all of the cables you need to run up and run down are tied up in those elastic, can't remember the name of those wraps. But those are high resolution pictures, and you can zoom in and get some real detail out of that picture. So it's a solution developed by one of the people in our club, and I think absolutely everyone uses it. And we have no more tangled cables.
So yeah, so you are one of the people whose mount does through the mount wiring or cabling, but you don't use it, correct?
That's correct, because you still, I mean, right, there are certain limitations to that. I don't even have this set up anymore, but with the new setup, I do exactly the same thing. The
Mhm.
two loops and the bundled cables.
There's one of the professional remote observatories. I don't know if they don't allow through the mount cabling or if they suggest against it, but I remember hearing them talking about it and kind of poo-pooing it, even though I use it, and I don't think I really have any issues with it, but I could see where internal cable drag could become a big issue.
Well, when I looked at the end, you could run certain cables through the mounts, but other things with everything on top, it really wouldn't work. But this works no matter what you have on top or what you have underneath. And I've seen a half dozen variations of the same thing. The key is the two loops.
Yep.
Those black loops that you see.
And another nice example of cable management on in our chat for Hyperstar system, which is probably, I'm trying to think about it, with a Hyperstar system, gets a little bit more complex because the camera's off the front. I don't know. I can't necessarily see if you've got an automated focuser on there, but I do see what looks like, is that a guide camera on the bottom of the dovetail, or is that a, no, that is a, the polar alignment.
Yeah, it's a pole master at the bottom.
Pole master, yes, yes. But definitely, each system has its own complexities, and cabling, cabling and power are probably our two most interesting presentations whenever they come up, just because we're all looking for some easy solution. There's no easy solution, but we're all looking for some way to just minimize that cable cluster, especially when it's -3 outside, and you know, all those cables are just hard as a rock, don't want to move, like it is now. All right, well, we've gone on well beyond our aim for 1 hour time. So I'm going to end the session for tonight. I'm hoping to come up with a session for next week. So we're not doing another open session. Hopefully it all works out. If not, I don't know, guys. Keep your both keep in mind some things you'd like to talk about. If you have a specific thing you would like to talk about and you are capable of presenting on it, then send me an email, contact me via the website, and I'll get you set up to do a presentation. You know, it could be anything. Maybe you're a machinist and you know what we have to do to get you information so you could build us parts. That'd be sufficient. Maybe you just have a cool processing technique. Maybe you want to review a piece of gear that you've got. Or maybe you've got a piece of gear that didn't quite work out of the box and you had to adapt it, and this adaptation you made on it works perfectly. Whatever it is, contact me, and we'd love to hear from you. This channel is basically, we rely on everybody, user-generated content to keep us going. So we appreciate it whenever it comes in. Thanks again, guys. Happy New Year, and I will see you next Sunday. Good night.